The goal of this section is to familiarize you with Newton's third law of motion and net force in one dimension. Earlier in this course, we discussed Newton's first two laws of motion. Newton's first law of motion states that an object at rest will remain at rest unless an outside force acts upon it. An object in motion will continue at the same speed in a straight line unless acted on by an outside force. Newton's second law tells us the force applied to an object is equal to its mass times its acceleration. Now, Newton's third law tells us that for any action by one of the two objects interacting, there is an equal and opposite reaction by the other. This is known as the law of action-reaction. In the picture, we see the man is pushing against a wall with a force of 100 newtons. The wall exerts a reaction force of 100 newtons against the man. The man is pushing on the wall, and the wall is pushing back against the man, causing the man to not fall over. If you swing a hammer at a nail and you strike the nail, the action would be the hammer striking the nail, and the reaction is the nail is embedded in the piece of wood. Here are a few more action-reaction pairs. In this balloon, the action is the air rushing out of the bottom of the balloon, so the reaction is the balloon going up in the air. The air moves in one direction and the balloon moves in the other. Next, we have a man firing a gun. The action would be the explosion in the chamber and the bullet shooting out of the barrel. The reaction would be the recoil of the gun. Last, in a boat, the action is the person jumping out of the boat. The reaction would be the boat moving in the opposite direction. Now that we've talked about the law of action-reaction, we will turn our discussion to net force in one dimension. When forces act in the same or opposite directions, the total or net force can be found by adding the forces acting in the same direction and subtracting the forces acting in opposite directions. In the next video, we will look at a few examples where we calculate net force in one dimension.